Okay, so this is the notes for the Absolut Extrema. So in our book, this is in Objective 1, and I usually teach it with the relative extrema just so that we can have a reference to what we're referring to. So just this is our definition of extrema, so absolute extrema here. So we have a function that is defined on some interval, and it contains some value of c. So we would say that f of c is our minimum value of f if it is the smallest number or equal to every function, every y value, for all x and I. So essentially this is just saying it is the absolute lowest point on the graph, right? So it is smaller than or equal to any point on the function for all x on whatever interval it is you're looking for, whether it's across the entire domain or a restricted domain. And then f of c would be our maximum value, right, of our function f on the interval if it is greater than or equal to, so the largest value, so larger than any point on the function, or equal to any point on the function, and again for all x on I. And again, I could be the entire domain, it could be a restricted domain, you know, just whatever it is. So essentially, it's kind of an intuitive thing. So it's considered the minimum value if it is the absolute smallest point on your function, and then the largest value would be our maximum, okay? And then one thing to kind of take note of is the fact that they're referring to f of c is our minimum, f of c is our maximum. So that means that we always want to answer in terms of y unless they specifically say otherwise, okay? So we always want to make sure that we answer in terms of the value of y, unless they otherwise tell you, right? Okay, so if they ask you, like, what is the minimum, what is the maximum, you should be saying it's at this particular y value. Okay, so just to kind of, you know, just to kind of get that sense and make sure that we're understanding. So let's say this is our function, and let's say we're trying to find the maximum and the minimum on its domain, so that would be all real numbers. So it has a relative maximum here, right, and a relative minimum here, but this would have no max, right, and no min, right? No maximum, no minimum, because the maximum would be its highest point, which because it goes to infinity, there would be no maximum. And there would be no minimum because it's going to negative infinity, okay? So no max, no min. However, if I restrict the domain, so let's say that I'm only going to look at a section of it, so let's say I just look at like this section right here, okay? So if I look at that particular section there, then it has a maximum, which would happen to be the relative maximum, as well, and it has a minimum, which also is the relative minimum, okay? So it would have both a max and a min, okay? And then one more here, so let's take a look at this graph right here. So this graph would have both a maximum and a minimum, okay? So its minimum also happens to be the relative minimum, and its maximum would be here at this endpoint, right? Not a relative max, but it would still be a maximum, okay? So this would have both a max and a min, and both of which are at the relative extrema, okay? And this one here has both a max and a min, where the min happens to be at the relative min as well, but the maximum at its endpoint, okay? All right, so a function does not have to have a max and a min, right, on the interval, whatever the interval is. So continuity or lack of it can affect the existence of both a maximum and a minimum of a function on a closed interval, or just if it goes to infinity, right? That would be the other instance. Okay, so let's go ahead and find our absolute extrema. So we're going to do a few things here. So I'll just do the steps off to the side. So our first step is we need to recognize that our absolute extrema are going to occur in general if we have a continuous function at either the endpoints or a relative max, relative min. So our first step then is going to be to find our critical numbers so that we can locate possible relative extrema, okay? And then just a reminder for critical numbers, we take that derivative and equal it to 0, right? So for finding our critical numbers, we would take the derivative, equal it to 0, but we would also look to see is there any excluded values, right? Any place where it might be undefined. All right, so let's go ahead and we're going to take that derivative. So we would have f prime of x, and that's just power rule, so that would be 2x to the first, and then plus 2x to the 0, which would just be 2. And then I'm going to take that and equal it to 0 and then solve. So subtract 2 from both sides and then divide by 2. So there is a critical number. And then once we find our critical numbers, then we're going to determine our absolute max and min by finding those y values, right? Because we have to answer in terms of our y value. So now we're going to evaluate the endpoints, okay, on your interval and your critical numbers. And so evaluate means find the value of y, right, whenever we ask for evaluate. So I'm just going to do a t-table. You don't have to do a t-table. You can do this all kinds of ways. Okay, so I'm going to just do x and y. And so I have my critical number here is -1, so I want to evaluate -1, my critical number, and the endpoints of my interval. So here's my interval right here. So the endpoints are -2 and 3. And so then I'm just going to replace x with -1 and then do that arithmetic, replace it with -2, and also replace it with 3. Okay? So I'm just going to write out the first one. From there on, I'm going to do everything mental math and hope that mental math goes well. Okay, so all I did was go through and replace x with -1, and I want to do it into my original function because my original function tells me y, right? Into the derivative would have told me slope, and I don't want to know the slope. I just want to know the y value. So I just did -1 squared plus 2 times -1 and then minus 4. So that would be 1 minus 2, which is -1, minus 4 is -5. And then I'm going to do the same thing again. I'm going to substitute in -2. And again, I'm going to do some mental math here. So -2 squared is 4. 2 times -2 is -4, and then minus 4. And so that would be 4 minus 4 minus 4. And so then that would give me 0 minus 4 or -4. And then one more, evaluate 3. So 3 squared is 9. 2 times 3 is 6, and then minus 4. So that would be, what, 2 and 9, so 11. So that would be 11. Okay, and then now, once I do that, then I'm going to make my conclusion. Okay, so your conclusion is the highest value of y, right? So the highest y is your absolute max, because again, we want to answer in terms of y unless we're told otherwise. And our lowest or smallest y is our absolute minimum. Okay? So I'm just looking at these three guys right here, right? Figuring out which one's the biggest or which one's the smallest. So 11 is my largest value, so then I would say my absolute maximum is 11. I don't care that it occurred at 3. Well, I mean, I kind of care, but not in terms of answer care. And then my absolute minimum would be the smallest value of y, and so that would be that guy right there, which is -5. Okay? And there we go. And I will warn you that I love to put a multiple choice question on there where I would say, like, what is the absolute maximum? And I would make sure that choice A was 3, so that you would pick that, because I'm devious that way, where the real answer would be choice B, which is 11. Okay, so watch out, people, watch out. All right, let's do one more. So if you feel pretty good about this, maybe hit pause, try it, give it a whirl, and then check your answers against mine. Okay, so step 1, find your critical number. So I'm going to do my derivative. So the square root is a power of 1/2, so I'm going to bring that 1/2 down. Don't you dare touch the inside yet, because you're still working on the power rule on the outside. Okay, so bring down the 1/2, subtract 1, and then you get that -1/2. And then now, chain rule, we're allowed to take the derivative of what's inside. So that would be 0 minus 2x, which is just -2x. And ta-da, there we go. All right, so then now I'm going to go ahead and rewrite this, clean it up just a skosh, because I know I have to substitute in and evaluate. So the 2 and the 2 cancel or divide to 1. So then I have -x in my numerator, and then the square root of 4 minus x squared. So then now to find my critical numbers, I'm going to set this equal to 0, but I'm also going to look to see where it might be undefined, right, where it might be undefined. So equal this to 0. In order for a fraction to equal 0, the numerator must equal 0, so then that means x is equal to 0. And then as far as the undefined values, I'm just going to do that off to the side. So my excluded values, so undefined, would be when this denominator is 0, right? And that would be at 2 or -2, so it's undefined at 2 or -2. But the nice thing is those are not in my interval, so I don't have to check those out. So woohoo, okay? So this is just information that is good to know how to find, but not needed for this problem. Okay, so then step 1's done. So now step 2, I'm going to evaluate. And so I'm going to evaluate my critical number 0. Don't need to do these because they're outside my interval. And then the endpoints of my interval. And then again, when I say evaluate, it means to go into the original function, f of x, because we want to find y. So we're going to replace x with 0. So that would be the square root of 4 minus 0 squared, which is still just 0. And then the square root of 4 is 2. And then now substitute in negative 1. So you would have 4 minus, and then 1 squared, or negative 1 squared is 1. So that would be the square root of 3. And one more, so square root of 4 minus 1 squared, which is also 1. Interesting. And so that would give me a square root of 3. So then now I look at my y values here. So I would say my absolute maximum is the highest value. So I know 2 is the same as square root of 4, right? So I know that square root of 4 is bigger than root 3, so 2 would be my absolute maximum. And so that would make my absolute minimum to be the square root of 3. Okay, and so again, it's not asking for the x values, just the y values. So it would have 2 locations, right, 2 places where it hits that absolute minimum at x equals negative 1 and 1, but there's only one lowest value of y, and that would be at root 3. All right, and that's it.